All right, let's take a look at the 3-2B notes. So first thing here, we have a warm-up that's going to kind of go over some of the things that we did in class yesterday. So what I'd like you to do is just take a second, pause the video, and give these 12 questions a shot. And then once you're done with them, jump back in and we'll run through them together. All right, so you should be back at it now, and we're going to run through this. And basically, we're going to pick a starting point and just work our way through the picture. All right, the only thing we know is that M is parallel to N. All right, so first of all, I've got 51 degrees in here. So angle 9 by vertical angles, all right, we can say is 51 degrees. So we can carry 51 in there. Now, angle 1 has to be supplemental with angle 9. So we need to find what would add to 51 to give us 180, which would be a 129. All right, and then vertical angles, we can go to 7, and we get 129 there as well. Now, one thing I want you to notice is how I'm attacking this problem, not even looking over at what order the questions are in. Sometimes trying to follow that order can make the problem a lot more difficult. All right, so next thing I'm going to do is I'm going to go in and use the fact that these two are parallel lines. All right, and I'm going to look for any corresponding angles that I see. So first thing I see is this angle up here where the 51 is definitely corresponding to 2. So I've got 51 degrees there. All right, we know that this whole angle here would be corresponding to this angle up here. So that whole angle is 129, which means angle 4 is 90. All right, we can use vertical angles to get that angle 5 is 39 degrees. And then if we have a 90-degree angle at angle 4, that means all 4 big angles around this are going to be 90, so we know this angle is as well. So 39 plus something would give me 90, and that would be a 51. All right, angle 3 is going to be another right angle because, again, the lines were perpendicular, so we have 90 there. That takes care of this whole section, and then we have 2 parallel lines, M and N. P is perpendicular to one of them, so we know that P is going to be perpendicular to the other one as well, which is one of our rules when we're dealing with parallel lines. So all 4 of the angles up here, we can say are right, so they're 90 degrees. So we can label them as we want to. All right, and now we've just got to run over to the side and kind of transfer all those over. So I've got angle 1, that was 129 degrees. Angle 2 was 51 degrees. Angle 3 was 90 degrees. Angle 4 was 90 degrees. Angle 5 was 39. Angle 6 was 51. Angle 7 was 129. Angle 8 was a 90. Angle 9 was a 51. Angle 10 was a 90. 11 was a 90. And 12 was a 90. And all of those are degrees. So we'll go ahead and give it a little marking up there. All right, so that takes us through the first one. So we basically just have to take the one piece we know and work our way through piece by piece using vertical angles, supplemental angles, and then I usually lean on corresponding angles next. All right, sliding on to the next one. These are just a couple of the properties, and it's in kind of a fancy symbolic notation. So first thing, how we read this. All right, so for this one, we have parallel, all right, lines, implies, right, corresponding angles are congruent. Now, we really don't want to write that out, so what we do is we use the parallel symbol, we shorthand corresponding, we use the angle symbol and the congruent symbol. All right, and then our if-then reasoning, so we still use the implication in the middle. So this says M is parallel to N. All right, so if M is parallel to N, that would imply corresponding angles are congruent. So we could talk about angle 1 is congruent to angle 3. Because 1 and 3 are in corresponding locations. Now, we could also look at 6 and 4. Those are in corresponding locations as well. All right, the next one is parallel implies alternate interior angles congruent. So they're still saying M and N are parallel. So I want to find a pair of alternate interior angles. So if I'm looking at the intersection of M and N, alternate interior would have to be on the inside of the two lines on opposite sides. So we're like angle 1 is congruent to angle 4. All right, and the next one, it says alternate exterior angles are congruent, and it's still lines M and N. So alternate and exterior, so opposite sides on the exterior, so that's angle 6, is congruent to angle 3. All right, the next one says parallel lines imply consecutive interior angles are supplementary. All right, so we want consecutive interior, which would be 1 and 2. So we're going to say measure of angle 1 plus measure of angle 2 equals 180. Or we could say angle 1 and angle 2 are supplemental. Now, the reality is that second answer I gave is probably the better answer, because that's directly what the implication gives us. But again, we can jump once we know they're supplemental. We know the two measurements add up to 180. 5 says if you have a perpendicular line to a parallel line, that implies it's perpendicular to the other. The notation on this one is super weird. So what we want to think of is we have two lines that are parallel. So in this case, M and N. So let me clean up my drawing. All right, so M and N are parallel. So I know this line and this line have to be parallel to each other. All right, then we know N and T, so N and the transversal are perpendicular. So we know we get a right angle there. So if we run through, what we want as a conclusion from that is that it's perpendicular to the other line, which makes sense because we've got a 90 here. They're parallel, so corresponding angles are congruent. So we get a 90 in there as well. So we could say that M is perpendicular to T. All right, so perpendicular and parallel implies it's perpendicular to the other line. Now, the next group of problems are really proof problems. And I really want you to take a second. I want you to read this problem, and I want you to make a mental argument as to why you think that the proof statement has to be true based on just the given information. All right, so now that you're back, we're going to take a look, and we're really going to look at the givens. So the givens are M is parallel to N, and T is perpendicular to M. So I'm going to mark up the diagram. I'm going to mark the two sides as parallel, and I'm going to mark the one perpendicular I know. Right? So the first thing that I can say based on that, using that last rule, number 5 up there, is we know N is perpendicular to T because, and we'll just use that shorthand, perpendicular and parallel implies perpendicular. All right, so if a line is perpendicular to one parallel line, it has to be perpendicular to the other parallel line. All right, now, if that is perpendicular, we know we have a right angle here. All right, so if we're looking at a right angle, all right, we have two angles that form a right angle. All right, so we can say angle 1 and angle 2 form a right angle. All right, so we know that N and T are perpendicular. That means that we have a right angle there. All right, we know 1 and 2 form that angle, so it has to be a right angle. All right, and if we have two angles that form a right angle, then their sum must be 90, and the angles are complementary. All right, so we can say angle 1 and angle 2 must be complementary. All right, so that takes us through the first proof. And it's just, we're given kind of a little bit of an informal argument to this, but it's really that logical process of how do we know it has to be true. So I'd like you to take a look at example 2 and kind of think through that yourself as well. So I'm going to give you a second here. Okay, so I went ahead and marked a couple things on the graph for us. So we have the two lines are parallel, all right, and then we have that BP bisects angle ABC. So that gives us that we know angle 1 is congruent to angle 2, right? Because BP bisects angle ABC. All right, we also know angle 1 is congruent to angle 3 because parallel lines implies alternate interior angles are congruent. All right, so we have angle 1 is congruent to angle 2, and angle 1 is congruent to angle 3. All right, so what we're going to be able to do now is we're going to be able to pull those two together because they're connected by the 1. All right, so they each have that 1, so 2 is the size 1 is, 3 is the size 1 is, so we're going to say, so angle 2 is congruent to angle 3. All right, and the fancy name for that is the transitive property. All right, and we kind of saw it in the logic work we did with the law of syllogism. That's where we're saying A goes to B, B goes to C, so we can bypass the middle person altogether and say A goes to C. All right, very similar setup with this. It's 1 is congruent to 2, 1 is congruent to 3, so we can bypass the middle one of 1 and just say 2 is congruent to 3. All right, and at that point, we've done exactly what they asked us to in the proof. All right, so this argument would be complete. Now, in our second to last one for the notes, all right, I'd like you to think through that and give that a shot. All right, so taking a look at this, I put a couple markings on there. We've got parallel lines, and we have angle 2 and angle 3 are congruent. So based on the parallel lines, all right, so because N is parallel to M, we know angle 1 is congruent to angle 2 because they're corresponding angles. All right, and we know angle 4 is congruent to angle 3 because they're alternate interior angles. All right, so I'm going to go ahead and put some markings here. All right, the 4 and the 3 are congruent. 3 and 2 we knew were congruent already. And then we have those two are congruent. All right, so there's a lot going on here, but we have 1 is congruent to 2, 4 is congruent to 3. All right, we know that angle 2 is congruent to angle 3. All right, so if I pull this together, I've got angle 1 congruent to angle 2, angle 2 congruent to angle 3, and angle 3 congruent to angle 4. So if I think about the connector on each of these, all right, I can really pull those together and say angle 1 is congruent to angle 4. All right, and that's what I wanted to prove, so that would take care of my argument. So running through, we can do really fancy two-column proofs with this, but we're really looking at the problem solving and the argument building on why we know the thing must be true. All right, we've only got one more, so let's take a quick look at that one together. All right, so we put a couple markings there. We have our two congruent angles at the bottom, the two parallel lines, and then we're trying to get to the two angles that have dots being congruent to each other. All right, so first thing we're going to do is I'm going to lean on corresponding angles. All right, and I'm going to add some labels here. So I'm going to say angle 1, angle 2, angle 3, and angle 4, just because it's going to make it a little easier for us to talk about. And I'm also going to add a 5 and a 6 down here. So first thing I can say is I can say angle 6 is congruent to angle 1, and angle 5 is congruent to angle 2, all right, because parallel implies corresponding angles congruent. All right, so now I've got this one is marked and this one's marked. All right, so from this, all right, I've got 5 and 6 are congruent. So since angle 5 is congruent to angle 6, and that was from our given, all right, we can say angle 1 is congruent to angle 2. All right, by vertical angles, angle 3 is congruent to angle 2, and angle 4 is congruent to angle 1. All right, thus, we could say that angle 3, all right, is going to be congruent to angle